Hey, nice to see you again. We're going to do definition 7.3.2 about joint continuous random variables. So let x and y be continuous random variables. Then the function f of xy is a joint probability density function. In the last video we were talking about mass functions for discrete. So joint probability density function for x and y if f of xy is always non-negative, if it's greater than or equal to 0. If the integral over all possible values of x and y, so from minus infinity to infinity for both x and y, if that total gives us 1, and if the integral from a to b and from c to d of f of xy dy dx is the probability that a is less than or equal to x is less than or equal to b, right? X is the outer bounds, and then the inner bounds, the probability that c is less than or equal to y is less than or equal to d. Now, it should be stated, we should remind ourselves that these are continuous variables, and so whether we write less than or equal to, it actually doesn't make a difference because the probability at a single endpoint is 0. And that's the same for the variables of functions of two variables. If we're talking about a single point, probability at a single point xy is still 0. Second part of the definition, if D is any planar region, then the probability that the random pair xy lies in D. So I can imagine some region of the plane, and here the probability that when I take a value of x and y, that it lies within that region D. So the probability that xy is in D is the double integral over that region D of f of xy dA. In the next video, we'll do example 7.3.2, where we'll put some of these concepts into practice.